Hey everyone, and welcome to the OWASP Cloud Native Application Security Top 10 Risks Flagship Project presentation for the OWASP 20th anniversary. Thanks to anyone who joined. I hope you have enjoyed so far the fantastic presentation at the OWASP 20th anniversary celebration. I'm very excited to be here and present for the first time ever this flagship project. The OWASP Cloud Native Application Security Top 10 Risks is a brand new flagship project that is still under development and supported by Oxide. We will have a fun half hour and we have a lot to talk about. So let's start. I will start with a short introduction about myself. So my name is Vider. I'm the co-founder and chief technology officer at Oxide. Oxide is a cloud native application security testing solution. Our goal is to find custom code vulnerabilities across multiple microservices and the underlying layers before they ever reach production in cloud-native applications. I've been around in the cybersecurity landscape for over a decade, since I learned how to hack when most of the web applications were vulnerable PHP applications. I built my first application security testing tool when I was 16. And in my free time, I like to search for vulnerabilities and learn about modern technologies. And in the last few years, I've been focused on the cloud security area. So, what are we going to talk about today? We will start with why cloud native application security is so unique that led us to build a brand new project. After that, we will discuss the challenges in cloud native application security that make it much more difficult. We will review our project leaders, and then we'll deep dive into each one of the risks. We will wrap it up and talk about how you can contribute to this fantastic project and take it to the next level. And as I said earlier, we have a lot to talk about and only half hour, so let's start. Cloud native applications are skyrocketing. Modern applications will be built as cloud-native applications. This is the de facto standard. When we are talking about cloud-native application security, we are not talking about cloud security or web application security. We are actually talking about the combination between them. Because in cloud security, we are securing the infrastructure. And web application security, well, cloud-native applications are not necessarily web applications. And when we are talking about their superset, the combination between them, it introduces a new type of security. Cloud-native applications are deployed as containers using orchestration platforms and service mesh technologies, all of which require additional security attention. When combining all of the above technology stacks into a single application, new risks arise, which is why we claim that this is a superset on steroids. This is what led us to build this new project, the Cloud Native Application Security Top 10 Risks. And this is exactly what we will talk about in this session. I hope you are excited as much as I do. Before jumping into the top 10 risks, let's take a look at why Cloud Native Application Security is different. So Cloud Native is not new. Therefore, why it requires a new approach to security? The shift to cloud native changed the way application look. In the past, we had a big chunk of code reading in a monolith architecture deployed on a web server somewhere on the internet. Nowadays, the application is built from many different components in a microservice architecture, and each one can be written in a different language and stored in a separate codebase repository. These microservices are installed on containers, managed in orchestration platforms such as Kubernetes, and deployed in the cloud, which can be a public cloud like AWS, GCP, and Microsoft Azure, but it also can be a private on-prem cloud. And this new approach didn't just change how the application works, but also the way risks are managed. For example, in the past, the risk for code vulnerability was mainly based on the code itself, from the entry point in the HTTP parameter through multiple classes and functions. Eventually, it ended in a dangerous function like a SQL query function. But now, it can start in the external microservice, go through multiple third-party components such as message queues and S3 buckets, and maybe 2 hours later, an internal microservice may read from it and the vulnerability is there. We can even add that the risk and the probability are not just affected by the code in the microservices, but also by the underlying layers. Is there any Kubernetes service that exposes the vulnerability? And what about the security groups? Do they expose the vulnerability as well? So now, after we talk about why cloud-native application security is different, let's move on to the risks. As I said earlier, the project is still under development. Currently, it is being developed by security experts from Oxeye and Palo Alto Networks. From Palo Alto side, we have Ori Segal, an application security expert with more than 20 years of experience. Ori is the co-founder and CTO of PureSec that was acquired by the cloud division in Palo Alto Networks. In addition to Ori, we also have Elad Schuster, a senior product manager in Palo Alto Networks. From Oxeye side, we have Dean Agron, the CEO of Oxeye, that brings his experience from Checkpoint and Imperva. And the last one is Daniel Abeles, the head of research in Oxeye, that prior to that, he was a senior security research team leader in Akamai. The project is available in OWASP Slack in a channel called Cloud Native AppSec Top 10, in our Twitter, and in our GitHub project Cloud Native Application Security Top 10. And we are looking for contributors that will help us to build a major project, and we won't be able to achieve that without you. But we will touch base again in the end of the presentation regarding how you can help. But for now, let's review the list. This is the OWASP Cloud Native Application Security Top 10 risks. If anyone wants to take a screenshot, go ahead. Let's go. Number 1, insecure cloud orchestration or container configuration. So an application is not a cloud native application without one major thing: the environment that the application is deployed on. We are talking about the cloud, which can be a public cloud or a private cloud, the orchestration platform, and the containers. And while we are talking about the misconfiguration of the environment, we focus on those who impose risk on the application itself. This is highly important because in such an agile environment, it can change very often. Many breaches in history happen due to misconfiguration of the environment, starting from publicly exposed S3 buckets with sensitive data to insecure managed services like databases. Now, we can even add that everything works with infrastructure as code technologies, and the potential risks are much higher than before and must be used carefully. A single commit to a misconfigured Terraform configuration file can make a highly secured cloud application become a highly exposed and vulnerable cloud application in seconds. Our second risk is injection flaws. Personally saying, I think this is one of the most interesting risks to talk about. Injection flaws are not something new, but the shift to cloud native brings to the table a huge change. When talking about injection flaws, it is important to notice that an injection flaw stretches on multiple microservices and multiple infrastructure layers. For example, we cannot just look at the custom code without knowing where it is deployed in the environment. How do you know on which containers it is deployed on? And does it receive input directly from the user or through internal components? Maybe it's from another service or a third-party service. And actually knowing that can increase or even decrease the score for the vulnerability. Determining the potential risk of injection flaws is much more complicated than ever. The number of parameters that affect is huge and must be considered. Number 3, improper authentication and authorization. Starting from the infrastructure to the application code itself. In cloud-native application, authentication and authorization can be implemented in many places. starting with the custom code that the developer poorly implemented authentication via the code, but it also can be implemented in the environment on each one of the different layers. In the cloud, it can be an over-permissive IAM role, but also in the cluster, it can be implemented through an extra-wide RBAC role. One of the first serious cloud-native breaches due to improper authentication was in Tesla back in 2018, when they accidentally exposed the Kubernetes admin console without any requirement for a password. It escalated pretty quickly because the AWS access key was in that Kubernetes cluster and had permissions to sensitive data in the Amazon S3 bucket. Okay. Let's move on to our fourth risk. Risk number 4 is CI/CD pipeline and software supply chain flaws. I'm sure many of you have heard about the recent SolarWinds and Kotkov supply chain attacks. Supply chain attacks are one of the biggest concerns right now. The application lives across the entire software development lifecycle, and not just in production, and it can be misused at any point of the process. Therefore, it must be secured and managed through the entire process. It can be the authentication in the CI/CD pipeline systems, but even the way we are building our Docker images and storing them insecurely in the Docker registry. The software development lifecycle of our cloud-native application is an integral part of its security. Securing cloud-native application, in the end, is not enough. It must be from the very beginning until they reach the end users. We're in the middle of the list, the fifth risk, secrets. Secrets are everywhere. We have plenty of them. It's our API tokens, our database and message queue connection strings, and it is even our password to the source code management system. Everywhere. The improper handle of secrets can be catastrophic. To store them in plain text in our code base is terrible. Using them directly while building Docker images is bad. And even if you keep them unencrypted, well, you should encrypt them. If hackers are able to grab your credentials to your Microsoft Azure account with the proper permissions, they will actually be able to do everything. Access any sensitive data in the account, log into running services, and even manipulate things in it. Improper handle of secrets can generate security issues in seconds. There are tons of stories regarding breaches that happened because an AWS access key was accidentally uploaded to a public source code repository. And even if it got deleted, they are still in the Git history. Let's move on to the next risk. Number 6, problematic network policy within cloud-native application. This is actually new from application security perspective. Well, network policies existed even when the application was a monolith, but not from the application side, but from the infrastructure. In the past, communication between different components was through the code and functions directly. But now, in cloud-native applications, it can be done through the network. You may think that your components within your cloud-native application are isolated, one from another. Still, with the incorrect network policy, they can see and talk one with another. For example, an internal microservice that does not necessarily should be exposed to the internet can be accidentally exposed and create a massive risk on the application. Another example is when an isolated container can access the network resources when sharing the network namespace with the host. This can lead to huge security issues. Number 7, vulnerable open source libraries, software, and third-party components. You can write your own code perfectly. You can configure your environment as securely as possible. But all of this will be irrelevant if you use vulnerable components, packages, or software. It does not matter if it is a vulnerable open source package you install via your favorite package manager, or a vulnerable software like an outdated HTTP server. And from cloud-native perspective, if you are building your Docker images with a vulnerable base image, or using a Kubernetes in an old version with known vulnerabilities, all of these examples are highly dangerous for your cloud-native application and can be used to attack your environment. You must secure your external components as they are your own custom components. The fact that someone else wrote it does not mean you don't need to ensure it is secure. We're getting closer to the end of the list. Number 8, improper asset management. In cloud-native applications, we have plenty of components that are being changed on a daily basis. We are starting from environmental changes in the infrastructure through new microservices and APIs. And if you don't know your assets, you can't secure them. So we are talking about tagging and documenting your cloud components, having API documentation for all of your APIs, and ensuring you don't have any neglected assets. The next breach does not necessarily will happen in the main core component in your application. It also can be through that one VM you initialized to debug your GCP account and forgot to shut it down. And having a proper asset management will help you to reduce the amount of these instances that might create a risk for your cloud-native application without actually knowing that. Number 9, inadequate resources. In the past, our resources were limited. For example, increasing the memory in our web servers in the past was a manual job, but nowadays, the resources are almost unlimited when working in such a dynamic environment, and it can be done easily using code or API calls. Now, hacker can abuse that for personal reasons without you will know about it. So in cloud-native application security, we are talking about limiting the infrastructure resources, limiting the API requests, and avoiding unnecessary high compute limits from a serverless perspective. That's me. No one wants a hacker to break into your cloud-native application and use your unlimited resources to mine cryptocurrencies for his own, and you're going to be the one that will pay for that. The last one for today, ineffective logging and monitoring. We just talked about in the previous slide that cloud-native applications are highly dynamic. And besides the management of their existing, we need to have a clear visibility for what's going on inside them. That's why our last risk is ineffective logging and monitoring. You must monitor your cloud-native application inside their code between the different microservices and the environment they are laying on. And actually, working in cloud-native environment, there are plenty of open source solutions that helps you to solve that problem and reduce the risk. For example, you can use open source telemetry solution to provide tracing within your cloud-native application and know what's going on between the different microservices. So we have just finished going through all the cloud-native application security top 10 risks. We talked about how applications have changed, and the result is that the risks have changed as well. Therefore, it requires a new approach to secure it. And that's why we are building the OWASP Cloud Native Application Security Top 10 Risk Flagship project. Then we talked about how modern security issues are a combination of multiple components, and to understand the actual risk, you must look at them all together and see how they're connected. And the last thing is when discussing application security in cloud-native applications, the environmental context is the key and cannot be ignored. And as I said in the first slide, the Cloud-Native Application Security Top 10 Risks Flagship project is still under development. We are looking forward to building a major OWASP project, and to do so, we need your help. These projects are created by the community for the community. And this is your chance to get involved in one of the earliest parts of the project. It does not matter if you ever contributed to any open source project before, or even if you have less experience, you are still more than welcome. At the moment, we are looking specifically for contributors and reviewers. So, to anyone who wants to get involved, or even if you just want to keep up to date with the product, feel free to join us in our Slack channel, Cloud Native AppSec Top 10 in OWASP Workspace, in our Twitter, and the GitHub project. I will post all the links in Slack immediately after the presentation. I'm looking forward to you joining us in building this amazing project. So this was the OWASP Cloud Native Application Security Top 10 Risks Flagship project. I hope you enjoyed this. If you have any additional questions, all of the project leaders, Ori, Elad, Dean, Daniel, and I, will be happy to answer them in OWASP Slack after we finish the presentation. Keep rocking and enjoy the rest of OWASP 20th anniversary celebration with awesome presentations ahead. And one last thing, I want to say a huge thanks to OWASP for the opportunity to build such a fantastic community, and to you for listening and making this world more secure. Thank you very much.